Okay, good morning, Cisco cohort. It's Thursday morning, October the 28th, and we're in the SBUS 1125 lab, and we're going to go the walkthrough of the 3.8.8 lab demo on DNS traffic. And I'm doing this as a demo because the student workstations in here have VMware, have WireShark installed on the VMware virtual machines, but they have no access to the real-world internet so that you can ping the Cisco. So I have installed WireShark program on my teacher workstation. It has access to the internet, and I'm gonna step through the lab and try to do the lab in the entirety as it's published there. So before I do that, I want to show a couple of things here at the DOS prompt. He uses a couple of commands here that you might not be that familiar with. Normally, if I wanted to ping something, I would do ping cisco.com. Yeah, we're rolling. And I'd get a reply back there. So the ping request goes out. Ping is an ICMP echo request. It goes out into the internet and to the DNS server, and you get to type cisco.com, because who wants to type in the binary 72.163.4.185? We cannot expect our users to do that. They will not type in binary numbers. So we use friendly names, and then the DNS service resolves that to the actual numeric address. It could be a 32-bit IP address. It could be 128-bit IP version 6 address. Now, there's a built-in routine on all Windows and Mac OS X and Linux machines called NS lookup, and it's sort of a utility that uses, I misspelled it, NS. It popped up, and it shows us that here's our DNS server. This is the internal Tarrant County College District DNS server, that 10.199.11.7, and that's the server that's located on DRTC. That's down in our data center, this downtown campus, the Trinity River campus that we bought from Radio Shack several years ago. So now I can type cisco.com, for example. It'll look it up. It'll tell us that it's still our server. You can go into this NS lookup. You can change the DNS server. Okay, here's my Gonzo secret insider tip of the day. You are not forced to use the DNS server that you get from your cable company, because some of the cable companies have been caught doing shenanigans that, like, good morning. Have been caught doing things like, if you mistype an address, you get targeted advertisements. So you don't have to use theirs. Now, Google has had one for many years at 8.8.8. Us grizzled old timers used to use the old Gentel, which is now Verizon 4.2.2.2. There's a couple of new projects opened up, like the Open DNS project. I think they're 1.1.1.1, and then they got one that's you can put on your kids' computers that'll filter adult material away. I like the Quad 9 project. 9.9.9.9 is easy to remember, and it filters malware type sites that could probably hurt your computer. So you could change that. You can leave your DHCP on, obtain the IP address on. But you can go to the bottom of the network control panel, and you can choose the particular DNS server you want without interfering with the DHCP server giving you the proper address on your home network or your other network. Now, here's another command that we haven't used too much before. We've used ipconfig all the time because that tells us what our IP address is. On my local workstation here, I'm 10.144.100.216. But there are some options with IP. When we did, let's see, did we do DHCP yet? There's a DHCP command where you can do DHCP/release and renew, and that should get you a new if you're doing the DHCP type lab. But he's going to use this one called ipconfig/flush DNS. He's going to have to do that in the lab to make sure that the DNS cache in your workstation is empty, because normally he holds on all these correlations between host names and IP addresses, which is what DNS does, for about an hour. And for the purpose of this lab to work, if you ping cisco.com in the last hour, he wouldn't have to look it up again because it would still be in his memory. So he's going to have you do that. And then I'm going to use in this WireShark program, which is a super duper packet tracer. And I'll tell you my little story, what we grizzled old timers used to have to go through. So in the 90s, I worked at a downtown office building. It was a college tech publisher, Harcourt-based college publishers. They bought by Pearson, I think, and they were wiped out. And I was the network manager, system engineer, network engineer for the site. We're running mostly Novell network stuff. And I wanted to troubleshoot a network problem. I needed a network sniffer. In those days, there was no free open source WireShark. There was a hardware product called the Sniffer, and it was a very superlative tool. The high-paid network consultants would drag the Sniffer into your company and hook it up and try to figure out what was wrong with your servers and network system. It was about $25,000. So our company headquarters was in Orlando, right across the street from SeaWorld. Yeah, we used to own SeaWorld. But we sold it because that's not our core competencies. So I said, will you send me your Sniffer? I want to troubleshoot my network. And they said, you're freaking kidding, right? No way are we going to send you this $25,000 tool. You're on your own. So they were not able to do that. So these days, anybody can get an inexpensive laptop computer, put a WireShark on it, and you've got the $25,000 tool. The guys used to use 20 and 30 years ago before this stuff was available. I'm a bit rant mode on. Mark's a big proponent of free open source software, like WireShark and Linux and things of this nature, as opposed to proprietary software like a Microsoft Windows operating system. 60 million lines of code. Oh, Windows, I think I found a problem with you. Windows 10 operating system. Would you send me the source code? I'm an expert programmer. I can fix it for you. And they tell me to get bent because no, it's proprietary software. It's not going to send it to me. So Microsoft has thousands of professional programmers that have developed this Windows operating system that's fairly lousy. And then we have the Linux operating system, which is written by a bunch of ragtag programmers from around the world for free. And that's the superlative operating system. Okay, rant mode off, back up the soapbox. So the first thing we're going to do on this lab is capture some DNS traffic, and I'm going to open up this WireShark program. WireShark, where to pull? I'll just do it like this. I'm going to select the production network, the current college production network, and he's going to show a bunch of stuff. Here's all the stuff that's floating around our network all the time. I already flushed the DNS server, so now when I go to and do the NS lookup program, go back to my DOS prompt. I'll do the NS lookup program. I think it tells me to www.cisco.com. And that's all in there now. So now I'm going to go and stop WireShark. It's captured a bunch of stuff. And there's pages and pages of stuff in here, but it gives you a code to filter out what's going on. We're going to, where's he tell us to do this? We're supposed to do the code DNS port equal 53. DNS UDP port equal 53. That's the port for DNS. Okay, so it filtered everything out except that step. Let me scroll down to the bottom of the list here. I'm looking. No, we don't have WireShark on the production desktop machines. It's only present on the VMs, and the VMs have no connectivity to Cisco or the internet. So I have to do this as a demo instead. Okay, let's see, where did it go here? I'll tell you what, I'm going to, let me see. Where the heck did it go? Is it at the top or the bottom? Oh. Should be at the bottom. Should be at the bottom. Let me clear it and make it do it again. Let's see, I'm going to, let's see, can I tell it to close and not save anything? Continue without saving. And before I start it again, I'm going to do see if I can quick draw McGraw thing here. Is it exit? There we go. I'll clear the DNS cache again. Okay. Config/flush. No tab completion. That flushed it. Now I'll go back to WireShark and start it again. Look how quick that garbage starts building up in there. And then I'll do the ping cisco.com. be enough for DNS to look it up. Now, let's see what we got here. It's not quite so much stuff anymore. What is going on here? Why can I not scroll it down? Oh, this is it right here. There we go. I have this UDP port. Why is it showing TCP stuff? There we go. There's the ICMP request. Okay, maybe I should do that again. Build the filter, and then apply the filter, and it was a UDP.port equal 53. Okay, I'm going to just stop and restart WireShark. I think WireShark's gotten confused. Our WireShark. The TCC production. And what if I go ahead and apply it right away? Let's see, UDP.port equal 53. And try to ping. There we go. Now we got it. Okay. So the lab tells us we're supposed to look at the traffic. So we're looking for the standard query. It's the standard query for it. We look at the bottom, we see at the physical layer, we've got the bits in the Ethernet frame that encapsulates the data. At the Ethernet layer, we've got the MAC addresses. So the source address was, the NIC card on my PC. And we have the Ethernet packet itself, rather the IP packet itself, which contains the source address and destination addresses. And then the user datagram protocol, port 53, that's to attract the attention of the DNS server for him to look up that address and give that back to me. And then the DNS name system response, this is the application layer response. And that gives us the actual information in there. Now, warning about the printouts you see in these labs. Sometimes printouts will not exactly match when you do the lab, because it may be a slightly different version of WireShark, or it may be a slightly different version of the iOS that's present on the router or the switch when you do that lab. So the MAC address is consistent with the MAC addresses that we have here. Let's go back up and look at the MAC addresses. Close the network layer, go to Ethernet layer. So here, this list is the source address and the destination address. So the source address is Dell. Yeah, I'm on a Dell computer. The destination MAC address, that's probably the default gateway on the router that's most closely connecting me to the rest of the Tarrant County College system. So let's say it says I have a MAC address ending in A91721. So how can I determine my own MAC address? I go ipconfig/all. Go back to my actual TCC production. A91721. That's the built-in Ethernet NIC card. I think it's an Intel chip. That's on our motherboards. Now, all of our PCs have 2 additional NICs attached to them. We've got a Broadcom card, and then we've got a USB attached card, so we can do our PCA and PCB and not interfere with that other stuff. So that matches up. So the source and destination IP addresses, are these associated with? Let's go back and look at the network layer again. So at the internet layer, source address, wasn't I 10.144.200.216? Yeah, that's me. That's me. Okay, so what's the 10.109.11.17? It's probably our internal DNS server, something like that. Let's see what our internal DNS server is. I did /all. For our DNS server. In that DNS servers, I don't want the IP version 6 ones. I want the I think I'm on the wrong adapter. Yeah, okay, here we go. So 10.109.11.17 and 11.18. Yeah, those are our servers. So that's consistent with what we're seeing here. So that's our IP addresses are good, and our NIC addresses are good. Now port numbers. Let's look at the port numbers. Port numbers is a source of confusion for a lot of fundamental students. Clients request services, and servers fulfill these requests for services. So I asked the DNS server to tell me what Cisco.com, what numeric 32-bit IP address it was equivalent to. Now, I'm not a server. I do not get to source information on low numbered port numbers below about 1,000. We have our well-known port numbers like port 80 for web, or port 443 for encrypted web. We have port 20 and 21 for FTP, port 22 for secure shell, port 25 for transmitting email, as simple mail transfer protocol. So when I create a request for a server to help me, I will make up a high number above 1,024. Now, different operating systems do this in different ways. In this case, my PC selected the port number 53,129 as its source port. And if I had run a second browser on my screen and pinged Microsoft.com, it would have picked another source number, maybe 53,130. Because the idea behind TCP and UDP is you can have multiple applications running on your desktop. How do we tell them apart? When that packet comes back, in this case from the DNS server to my desktop PC, how does he know which application to send it to? He's going to match up. In this case, when he sends it back to me, the source port will be his 53, be my destination port will be the port on my machine. And if I was in Windows, you can do two things at the same time. You can do maybe 10 things at the same time before it crashes. So this means when you're running two web browsers or running two tabs on a web browser, each one will get the response it's supposed to have. They have individual, different high-numbered, what we call ephemeral ports, high-numbered ports. So 53 is a server. I attracted the attention of that server, which is a rack mount server in a data center somewhere. And he responded and gave me that particular address. So most of the time, many shops are Microsoft. I think we're a totally Microsoft shop. I think the only Unix machine we have is the one that we use for, what's it called? It's the Oracle database. Okay, Oracle database is the worst company in the world to do business with. They're mean, but they make the best databases everybody uses. And they won't run on Windows because Windows machines crap out if you try to run Oracle database on it. It's too big and complicated. They run on Unix machines. So normally, though, when you set up a small or medium-sized business, many companies will choose Microsoft. We're a Microsoft shop. We have agreements. Microsoft gives very good discounts to education. That's why you guys can get free copies. Go to Microsoft Azure on your MyTCC, you get free copies of all the Microsoft software. They offer everything in the world. You get free Microsoft Office, everything that you need to do stuff. It's not supposed to resell it to anybody else. So normally a company would set up a Microsoft server, a big piece of hardware with 16 CPUs and 16 gig of RAM or something like that. And they would set it up and they'd install Microsoft Server 2019, something like that onto it. And they would make it a file and print server for the company, shared files. They would make it the DHCP server for the company. Because you could use your Cisco router to be a DHCP server, but it's more expensive to do it that way. You would be the DNS server. It would be all these different servers for the company. I want to attract the attention of the company server for a DNS lookup. I'm going to send my request to them with my ephemeral 59,000, and I'm going to say port 53 on that DNS server. That's going to attract the attention of the DNS service. If I want to attract the attention of the DHCP server and give me a DHCP address, that's what port 67, 68, something like that. It would get that number and give it back. If I wanted to send an email to the Microsoft email service, Microsoft Outlook, I would do port 25. So they use different port numbers to respond to this. Port number is a 16-bit value, right? 65,000 different possible values. So the low numbers below 1,000 are resolved for servers to use, and then the numbers above those are resolved for others. Okay, so our port numbers are consistent. Now, he says, instructing us to go to the DOS prompt and do the ARP. And I've talked more than 3 minutes now, so it might have wiped it out. ARP-A. Now, I have a Big Brother software. We use Big Brother type softwares on our lab machines in here so we can see, well, for me, it tells you, who's logged in. I can take roll and stuff like this. I get a little postage stamp size picture of your screen if I want to see that. because we have rules here. You're not supposed to Facebook, or basically you're not supposed to go anywhere you wouldn't want your mother to see you doing something. It's supposed to be for student educational purposes only. So I've got all you guys IP addresses of all the students that are not on standby in this room showing up in here, because every few seconds it updates that little. I'll show you what it looks like. You probably want to see what Big Brother looks like. I'll pull it over here and put it on the screen. So you're gonna let me do it. Oh, it's so big. Let me shrink it here. It's on the screen with super high resolution. Let me make it kind of small, and then when I pull it over here, there we go. So I can see, you know, who you logged in and role and stuff like that. But I can also see a little picture of what you're doing. I can even take over your PC. I can see the last website you went to. So if we're taking a test, a closed book test or something like that, I can make sure you're not going to, you know, IT exam answers or something like that. Look at the answers. I'll pull this back over here. Truth in advertising here. So I did this ARP-A here, and I want to record all the MAC addresses, PC addresses. I'm not going to write them down, but this is all the correlations between all of 10.144 to 44. So these are the local addresses that are present here. And what was my work? Oh, 10.144.100.1. Normally, when you see a .1 address, traditionally that's your default route. Your default gateway, we used to call them gateways, before we call them routers. I would call them default gateways. I like to call it, like from Mr. Rogers' neighborhood, your friendly neighborhood router. This is the device you're most closely connected to, and he'll relay all the messages out to the rest of the world. So that's probably, if I type the command plain IP config, verify what my default gateway is. Yeah, it's 10.144.100.1. That's my default gateway. That's at the top of the list. We have all these dynamic mappings here, and then we have some multicasting addresses and things of that nature. And I think that the Insight Big Brother software that we're using uses multicasting to capture the student screens and bring it to up to the screen here. We typed ipconfig/all. We got consistent results between all the others. And we looked at the DNS stuff, response traffic. Okay, so I think I've stepped through everything I need to do here. Okay, hang loose. I'm going to stop the recording session.